Hello, today I'd like to provide an insight into the Floating Offshore Wind Environmental Response to Stressors, or FLOWERS project. FLOWERS is led by CFAS within a portfolio of Crown Estate funded OWEC projects. And whilst the presentation is mine, I really must acknowledge the great contribution of my colleagues at CFAS and our collaborators within the Scottish Government. Furthermore, many thanks go to the excellent engagement of the cable operators, wind farm operators and the national grid. The overarching aim of FLOWERS is to assist with the pre-EIA stages for floating offshore wind developments through providing standardised approaches to considering poorly understood stressors. The outputs will be useful for the consideration of these stressors, particularly in the context of future offshore wind planning, in order to reduce time spent during the environmental assessment process and improve confidence for those applying and those assessing projects. There's three main objectives to FLOWERS. The first one deals with sea shelf scour, the second one deals with electromagnetic fields, and the third one is an initial framework to consider multiple stressors. For this presentation, I'm focusing on number 2, electromagnetic fields. To address the EMF work package, we had 4 objectives. The first one, to define the actual EMF environment via field measurements. There's very few dynamic cables around, therefore we took advantage of the fact that the magnetic field emissions are comparable whether it's underground, whether it's in the water, or whether it's in the air. This is reflected in the top right panel, where the red circles represent the magnetic field emission. Note this is not the case for any associated electric fields. The second objective is to use the field measurements to verify the predictions of the EMF extent obtained via basic EMF models that are currently used. Our third objective, to estimate the spatial and where possible temporal overlap between selected species occurrence and cable routes. And the final objective, to develop a version 1 method to estimate the likelihood of encounter as a proxy of relative risk of EMF to selected species. During the fieldwork in 2024, we used 2 magnetometers attached to a frame. This is used to understand the propagation of the magnetic field intensity with distance from the cable. We set up transects in the shallow intertidal or on the beach, depending on health and safety considerations, and that was perpendicular to the cable route, as shown in the middle pictures. We sampled every metre for 10 metres either side of a cable, and reached out to 100 metres away on one side. We undertook surveys in the 4 red boxes, shown in the map on the right hand side, where we recorded 12 high voltage AC cable routes and 2 high voltage DC interconnectors. So, what did we find? Here's a selection of raw plotted field data. It's for illustration purposes only, please note. It shows a magnetic field peaking near to the cable and dropping off over distance, as you might expect. These data come from cables that vary power transmission, and we still need to standardise by the power transmitted to compare with model predictions. The red bands on each of the graphs show the estimated lower limit that we know of species detection of magnetic fields, bearing in mind that these are very sparse data. The distances under the red bands indicate the zone where the EMF is above this lower limit. It's worth noting that these are the order of tens of metres, and part of the reason is that most export cable routes have more than one cable, as you can see by the multiple peaks in these graphs. The EMFs from each cable will interact, and this means from the perspective of the animal that if they encounter the EMF zone, it will be over tens of metres rather than a couple of metres that's widely recorded, usually based on modelling. We have a model for the national grid that we're currently using to compare the measurements with and therefore validate the models. The final part of the project brings together the EMF data with the species distribution data. We've drafted a step-by-step framework which will allow the main categories of input set out on this slide. That's the EMF environment based on the cable characteristics and the validated modelling, the occurrence or distribution of the species of interest, first in 2 dimensions, and where possible in 3 dimensions to include depth and temporal distribution. And combined together we can assess the overlap and therefore the potential encounter, which is indicated in the bottom right diagram here. So by taking the engineering aspects and the species aspects and combining, we'll have a method that can be applied to any cabling type and species of interest, and this can be applied to planned floating offshore wind areas. In practice, we anticipate our step-by-step framework approach to guide realistic cable modelling to determine EMF buffer zones for spatial overlay, This can give buffered cable routes in GIS spatial maps, which you can then overlay with target species occurrence and density if possible, as indicated here. Then we need to consider the 3 dimensions that the animals operate within and determine the vertical overlap of the EMF buffer zone up into the water column and the known depth of occurrence or likely occurrence of target species. If there's no overlap, such as the fish in the middle of the diagram here, then we expect little likelihood of encounter and then hence reduced potential for impact. And this perhaps allows this species to be scoped out of the EIA process. If there is overlap in 3Ds, such as benthic species on the left-hand side, or on the right-hand side, the species in the water column with the dynamic cable, then we might then consider temporal occurrence, such as seasonality, if we have those data, to then determine the likelihood of EMF impact within the EIA scoping. It may result in a need for specific data to be collected or recommendations for monitoring. Overall, we anticipate this approach will reduce some of the uncertainty around whether to take EMF into account or not. There are some important evidence needs. Species habitat use is really important, particularly in relation to depth, and we often don't have enough data for that. We need to think about life stage aspects, as some may be more likely to encounter than others, such as benthic spawning versus a pelagic adult phase. We need knowledge on how cable EMF varies, such as during the day, over the year, seasonally, and link this to habits and life history of species. And we need data available from transmission operators that's in a standardized manner. This will all go towards more confidence in determining the potential for EMF impacts through a more realistic EMF environment associated with the cables, and the likelihood of encounter also being based on the life history characteristics of the species. Thanks for listening, and thanks to ScotMER for the opportunity to present our flowers EMF work package. We anticipate the final report being submitted to the Crown Estate during May this year, and hopefully approval for release in the weeks following that. Thanks again.